Hey Math 1, let's take a look at task 3.3, okay, which are looking for some special points on a graph. Okay, so take a look at this. There's a couple things I want you to notice. This is your savings account. Your money's going down and up and down and up, okay, and these are days, okay, over 15 days. So where are some special points? One of the places I want you to look right here, okay? This is how much money you started with. This point is special because it's on the y-axis. Okay, so let's go ahead and write these things down. We start with $40. Okay, that's on the y-axis. Okay, so we call that a y-intercept. The y-intercept is 0, 40. Okay, so we write that as a point. How about where we touch the x-axis? Okay, do we ever have $0? Yeah, a couple times, right? We have $0 here and $0 here. So when do we have $0? Okay, we have $0 at day 7 and day 10. And day 10, okay? And those touch the x-axis, so these are X-intercepts. And the way that you write an X-intercept is 7, 0 and 10, 0. Okay? Now I want you to look and see what's the most amount of money ever in the account. Okay, the most amount of money we ever have is up here. And this, okay, this is called a maximum. This is called a maximum. That's the highest. I don't think there's any other days where it gets to be $140. Okay, sometimes you could have 2, but there's just 1 right here. Okay, so this is where it gets a little different. So the maximum is $140. Now, how do we write that? Okay, we have to say the max is $140, but you have to say when. When does that happen? That happens on day when X is day 12. So the maximum happens on day 12. Okay, and that's what's a little different about max and min. You have to say when that happens. How about the minimum? How about the lowest this graph ever reaches? Okay, and the minimum value right here, oh, maybe you owe somebody $40. Okay, so this is the minimum. There could be more than one minimum if they were both the same. So the minimum is negative $40. So how do we write that? The minimum is negative 40, okay? When or on, you could say on day, what is that, 9, on day 9. Okay, so when you're doing maximum, you have to say when that happens. When does that happen? When you do X and Y intercept, we have the 0 there. All right, let's take a look at some myths, okay? So when we have a point, okay, a point, you say X, comma, Y. And that's what an X-intercept is. So an X-intercept is a point, okay, where the graph crosses the X-axis. Where it crosses the X-axis. So let's go see if we can find some of those. Points crossing the X-axis. Oh, there's a couple of them. One's right there, one's right there. So we're going to have 2 answers this time. Okay, and how do we say that point? Negative 4, 0. Okay, the X value is negative 4. And that point is negative 1, 0. Okay, so those are points. A Y-intercept. Okay, a Y-intercept. It's also a point. It's a point where the graph crosses the y-axis. The y-axis. So let's go see if we can find it. Here's the y-axis. I'm looking, oh, and here's the point right there. Okay, if they don't have one drawn, you can add one in, and that is the point 0, 3. Okay, it's a point. It's a point. And then remember how stuff got a little different for max and min? Okay, so a maximum. Okay, maximums, you can have many. A maximum is the highest y value that the graph reaches. Okay, so let's go see what's the highest this graph gets to. The highest is 5. Okay, so there's the maximum. But this is how you say maximum. Okay, the highest it gets is 5. Okay, and when does that happen? That happens at x equals -6. So it's a little different for maximum. Okay, you have to tell me the highest and then when. Same thing for minimum. Okay, to state the minimum, we're going to be looking for the lowest y value. The lowest y value. So let's go see if we can find the lowest point. Here it is. Here's the minimum. Okay, so how low does it go? The lowest it goes is -5, but when does that happen? For x equaling -2. All right, so these are a little different. These are value telling me when, and then intercepts are points, because these are always going to have a 0. Okay, these are going to have different numbers sometimes. All right, let's draw a graph. A graph that shows the amount of money in an account. Okay, so the graph starts with $0. I'm sorry, $10. Starts with $10. That's going to go right here. $10. Okay. The most amount of money in my account that it ever had was $90. Okay, so that's going to be the most I ever had. Happened on day 3 and 7. So let's go see. On day 3, I had $90. And on day 7, I had $90. Wow, that's the most I ever had. Okay, the least amount of money I ever had, the least amount was $0 on days 1 and 6. Okay, so day 1, I had nothing, and day 6, I had nothing. Okay, the account ends with $50 on day 10. So if I go all the way to day 10, I'm going to end with $50. So what does this graph look like? What's happening with the money? Okay, so I know I started with $10, and then my money went down. I must have spent or paid a bill. Okay, and then 2 days later, my money increased all the way to 90. Okay, so I put some money into the bank account, went up. Oh, and then day 6, I must have spent all the money or paid a bill, so then I got to go all the way back down. Day 7, I put some more money in the account, and then I ended with 50. Okay, good job drawing that graph. Okay, and here's some questions for you. Can a graph have 2 y-intercepts? Okay, so a y-intercept, we're going to look over here on the y-axis. We're going to go look on the y-axis, okay? Can you ever have 2 y-intercepts? And the answer to that is no. No, you can't have 2. You started with $10, okay? You can't start with 2 different amounts. We can only start with 1 amount of money. You can only start with 1 amount. It was $10. Can you have 2 X-intercepts? Okay, so X-intercepts, we're looking along the X-axis. Can you have 2 of them down there? Can you have $0 and $0? And the answer to that is yes. Yes. Okay. You can have $0 several times. Yes. You can have $0 every time you spend all your money. Why not? Okay. Can you have more than one maximum value? Can you have more than one maximum? Let's go see, where's the maximums? Can we have 2 maximums? And the answer to that question is yes. Yes. Okay. We can have the same amount of money several times. You could have $90 and then $90 again another day. Yes, as long as they're both 90. Okay. Can you have more than one minimum value? Can you have more than one minimum? Let's see, what's the lowest this graph ever got? It got down to 0 and down to 0. Can you do that twice? Yes. Yes, you can have $0 several times. Or even lower than that, right? Okay. I want us to do a little recap of solving some equations here. Okay, so here's what we're going to do. To solve an equation, we're going to build a wall. Okay, so you look for the equal sign. You build a wall on the equal sign. Why do we do that? Okay, the equal sign tells us the left side and the right side, and it's super important that we see those two sides. Okay, find the variable. So I'm looking for the variable, okay, and I see the variable. The variable is right here, x. Okay, our job is to get x alone. Okay, why is the variable not alone? Why is it not alone? Okay, well, because it has this minus 11 here. Okay, why is it not alone? It has minus 11. Okay, so we have to get rid of that. And to do that, okay, we're going to use the inverse operation to get the variable isolated. Isolated means to get it alone. Okay, to get it alone, to get it isolated. So what's the inverse of minus 11? Okay, what's the opposite of that? Okay, we need to add 11 to both sides. To both sides, okay? So if I add 11 to the left side of the wall, I need to add 11 to the right side of the wall, okay? So what happens when we do that? The minus 11 is going to cancel with the plus 11. That's why we picked that. That's awesome. So what do we have over here? All we have left is the x. Perfect. Over here, 15 plus 11 is 26, all right? And it's super, super important that right here we put the equal sign, okay? So our answer is x equals 26. We solved for x, okay? Solving means you find the value of the variable. Solve the equation means find the value of the variable. The variable could be x or it could be any other letter. X is equal to 26. Let's do it again. Okay, step 1. Find the wall, or find the equal sign, build the wall. Okay, ask yourself, why is x not alone? Because it has a plus 8. The inverse of plus 8 is to minus 8. What you do to the left side, you're going to do to the right side. Okay, and when you do that, the 8's should cancel out. We have x all by itself. We have equal sign, and x is equal to how much? 5. X is equal to 5. Okay, now there is something that I want you to do, okay? And we're going to check to see if this works. we're going to check, is that the right answer for x? We're going to put that number there. Okay. If x was a 5, let's check. X is a 5 plus an 8. Does that actually equal 13? And the answer is yes. Yes, it works. Okay. All right, step 1. Let's build a wall. Build a wall. Where does the wall go? It goes right on the equal sign. Okay, build the wall. Number 2, find the variable. Number 3, why is the variable not alone? Because it's being multiplied by a 3. The opposite of multiply is divide. So we're going to do divide by 3. Divide by 3. Okay. 3 divided by 3 cancels out, and we have x all alone. 27 divided by 3 makes a 9. Okay. But remember, I want you to check. Is that the right number for x? Let's see, this problem said 3 times x number. I think it's a 9. Does that make a 27? Yes, it does. Yes, it works. Okay, example 3. Let's build the wall. Build the wall. Let's find the variable. Here it is. Why is it not alone? Well, I see minus 10. The inverse of subtraction is addition. So I'm going to add 10 to the left side and to the right side. Okay. Negative 10, positive 10, that should cancel out. And what do we have left? Our x equals 34. Okay, let's go ahead and check. Make sure this works. I think the number for x is 34. Let's put it right there and see. Does the number 34 minus 10 make 24? Yes, yes, we got it right. Okay, last one. We're going to build the wall right on the equal sign. Okay, let's find the variable. Why is that variable not alone? What's happening to x? It's getting divided by 5. What's the inverse of divide? Multiply. Okay, so I'm going to multiply the left side, multiply the right side. I'm going to use a dot for that. 5 divided by 5 is going to cancel. And we have x equals. What you do to the left side, you have to do to the right side. And that makes 20. But remember, we have to check. We have to check to make sure. Is 20 the right answer for the x? Okay, 20. If we divide it by 5, does that make the 4? And the answer is yes. Good job, Math 1.